Hey everyone, welcome back. So this is going to be the first video where I start talking about some of the content for this class. Now, a few things before I start. We're not going to be going straight into the physics. In fact, I just want to talk a little bit about some side math stuff that you're going to want to kind of be comfortable with. So there's two lessons that I'm going to talk about. For this video, it's going to be strictly on the scientific notation type things. So it should be a little bit on the shorter end. And then later on, I'll talk a little bit about units and metric approximation. Both of them are really big in this course. Now, on Canvas, there should be a guided note packet. I highly recommend that you print it out and you kind of follow along with me. Most of it is pretty much the, you know, uh, areas where you can do practice questions. Of course, that could be done on a separate sheet, but what's really important is the parts of the notes that I deem the most important is pulled out into there, and you kind of have to fill in the blanks. So uh, it's really beneficial to you if you get a paper copy out and you kind of write it down, just so that you know what from these slides is important and what can kind of be passed over. All right. So a few things. You've probably, as you've taken chemistry there, I know that there are a few things that you might not have liked. One of them was sig figs or significant figures. If you recall, things like if you have a number that is three significant figures and it's multiplied by a number with two significant figures, you should know how many your answer is supposed to have. We don't care about that in this class. So physics does not care. Hooray! Now, the one thing that I do want to point out is that you want to try to keep your numbers to about 3 to 4 sig figs. I know I just said that we don't care about it, but the reason I say this is because if you round your number too much, then it runs the risk of you being off. So you won't be penalized if you have it to 2 sig figs or 5 sig figs. Typically, you'll only be penalized if you have unnecessarily too many sig figs like this. Like if you have this number 5891 point blah 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 blah. Yeah, that might you might lose points on that. Instead, you'd want to round it to something like 5,890. That's good. Or if you wrote it to 5900, that also works. Or 5891 also works. Again, another thing when I said was rounding it too much, something like 6,000, you might lose points off on that. I've had a few people have that issue where the answer was something like 4.4 and they rounded their number to 4, but it was something where you really needed to be as precise as you could in that. So keep it to 3 to 4 sig figs and you'll never have to worry about losing points. All right. Now, one of the things that we do use from chemistry is the concept of scientific notation. So that whole idea of taking a number that is either too big or too small and writing it in a much nicer way. So as you should know, scientific notation, there are two important numbers. There's a base number and then an order of magnitude number. So a good example of a number in scientific notation is something like this: 3.45 times 10 to the fifth. The 3.45 is your base number, and the 5 is what's called the order of magnitude number. Basically, the idea about the order of magnitude is it just tells you how many zeros there are, or how big of a number that is. Is this a number that's in the thousands, in the millions? What is it? So like 10 to the third means that your number is in the thousands. That's how big the number is. If the number was to the sixth, you're in the millions. This is kind of similar to if you've ever heard the phrase on movies or TVs when someone's saying like, "Oh, I make 5 figures" or "I make 6 figures." That's usually referring to 5 figures being like 100,000, 200,000, some number in that 100,000 range, while making something like six figures is in the millions range. Again, it's just kind of giving you an idea of how big the number is. Another example for something that's really small would be 6.89 times 10 to the negative 8, the negative meaning that it's a small number. I'm not really going to go into detail about how to write a number into scientific notation. As you should know, the exponent just tells you how many times you move the decimal place over. So in the first case, that 5 exponent tells you move it over 5 times. In the second case, the 8 tells you it moves over 8 times. The only difference is you go in the opposite direction because it's a negative 8. So here, let's do some practice. There's a few practice questions in your notebook and the guided notes, so you can write it there. But I want you to rewrite these two numbers into scientific notation. So pause the video, work on the self, and we'll go over this in a second. Okay, so what we're going to do, I'm just going to pull up Paint real quick. This is the only way that I can actually write stuff. So our first number was 150 000 000 000 meters. So my decimal place is right here. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my number would be 1.5 times 10 to the 11th. Typically, you always kind of want to write the number so that it's right in front of whatever your first number is. All right, so that's the question 6. And question 7, 0.0000006. All right, so once again, I move it this time to the other side. So 1, 2, 3, 4, 5, 6, 7. So 6 times 10 to the negative 7. All right. Do it again. So we have these two numbers. So again, pause video, work on self, and we'll go over in a second. All right. For question 8, the number is 9070 000. Once again, 1, 2, 3, 4, 5, 6. So 9.07 times 10 to the 6th kilograms. So my base number is the 9.07, and my order of magnitude is the 6. And the last one, let's make that smaller, 0.005 meters per second. 1, 2, 3, 5 times 10 to the negative 3 meters per second. So that's pretty much it for the scientific notation. There is one last thing that I want to talk about, but I'll just mention something really quick. So one of the benefits to understanding how to write numbers in scientific notation is, first, it can really speed up a lot of your math. For example, if you have a bunch of numbers in scientific notation, if you know the trick to dealing with numbers multiplying in scientific notation or numbers being divided in scientific notation, then what you can do is just worry about the exponent, and that can help figure out what you're going to be doing, what the answer is. A lot of times in a multiple choice, you'll have 4 choices, and each one may have a different exponent. So it makes life easy because the whole trick with the exponents are that if you're multiplying, they add the numbers. If they're divided, you subtract the numbers. So you can easily do some simple math and addition for the exponents in order to figure out your answer. But again, you have calculators, so use them. Also, it will help be able to convert easily into different units. All right. Now, the one thing that I really need to stress about this is when you plug numbers into the calculator with when they're written in scientific notation, because it's very common that they're going to give you questions. And definitely in the later topics, they'll give you questions with numbers in scientific notation, and people will end up getting the wrong answer. They'll figure out what the correct equation is. They'll know where all the numbers go. That's pretty much 80% of the battle. And all they have to do is just plug it into the calculator and write down the answer, and then they'll fumble it because they make a mistake on the order of operations. So the way the calculator runs is if you don't specify the order of operations. So for example, let's say you're writing the equation in the calculator 5 times 10 to the third divided by 6 times 10 to the 2. The way, if you write it like this, it's this number being divided by this number. But if you type this into a calculator, like a scientific calculator, not a graphing calculator, it would look something like this. But the way that the calculator reads it is it would read it as 5 times 10 to the third being divided by 6 times 10 squared. This is not the same thing as what we had written up here. So the whole idea is that you have to force the calculator to use the right order of operations. Now, one method of doing this is putting parentheses around your numbers. So going back to here, if you put a parentheses around the first and second number, then the calculator will read it as this first part up here, which is what you would want. So use parentheses whenever you have scientific notation, or just for the most part, I tend to do it all the time. And this forces the equation to look the way it's supposed to. Another method, I didn't write it in here, but since a lot of you are probably going to have graphing calculators, and I actually have graphing calculators in the room, you can actually set it to be written in fraction form. So you can write it like this, and that also saves you a bunch of hassle. But another thing that you could do, if you don't like the parentheses and you don't want to go through the hassle of writing into that fraction form, you can use the EE notation. So in the graphing calculator, typically on most calculators, it's right above the 7. So you would normally have to go into the second and then hit here. You would see these two capital EEs. What this does is it gets rid of the whole times 10 to the factor and allows you to turn it into one complete number. So a good example, so this number 3 million, you can write into a calculator like this, 3 times 10 to the 6th, or if you're using the EE notation, it will look like this, 3E6. So you have your base number, and then you're giving your order of magnitude number. So that's pretty much it. 3 times 10 to the 6th. A lot of times if you have a calculator and you have a number that's too big or too small for the calculator to write it all, it will actually give it to you in this form naturally. So just be aware of that. If you see a capital E, it's usually a scientific notation type thing. And like I said, I usually recommend this. This tends to be a better one because you don't have to worry about parentheses. But personally, I always say might as well use parentheses. All right. So I want you to do this. I want you to practice putting into the calculator. So pause the video, work on itself, and we'll go over in a second. Okay. So there are two ways to write this. Again, you can write it with parentheses around it, or you can write it with the E in the EE form. And in both cases, you should get the same answer. It should be 8 times 10 to the negative 2, I believe. I didn't actually do that. Yeah. So this, or you might have it written like this. Same thing. I doubt you'd have it written like this, but you could also have it written like this. Either one gets you the same answer. All right. All right. Here's the next question. So pause the video, work on yourself. Go over in a second. Okay. So again, if you're not using EE, you want to put parentheses around this. If you're doing it, you don't have to worry about it, and this is what it would look like. For both cases, the answer would end up being in non-scientific notation, or in standard notation, it would look like this, 0.00055. If we were going to write in scientific notation, it would look like this, 1, 2, 3, 4, or 5.5 e negative 4. One thing that I would recommend is try doing question 10 and 11 without parentheses and without using the e function or factor form, whatever, the fractional form, whatever you did if you ended up getting this answer, and see if you would still get the same answer. What you should note is that question 10 will end up being the same, but 11 is where you would end up getting the wrong answer. It's really only when you divide scientific notation that you really have to worry about this whole order of operations, putting parentheses. But my big recommendation is just do it from the beginning. That way it becomes a second hand thing, it becomes natural, and you just do it that way right from the get-go. All right, and that's pretty much it. If you have any other questions, feel free to send me a message on Remind or come to one of the extra help meetings and ask me there, or you can always ask me in class if you're going to end up seeing me. All right, see you later.